Okay guys, so let's start 6.15 question of exercise. Write the mechanism of the following reaction where NBuBr plus KCN in presence of ETOH and water gives NBuCl. So first of all, you should know what is the meaning of this BuBr and all that stuff. Remember, this means NBu means butyl bromide. Okay. In presence of ETOH means ethyl alcohol or ethanol, you can say. Okay, and BuCN means N-butyl cyanide. So this is what they are asking. So let's draw the structure first and then we will find out how it will work. Okay, so butyl bromide, N means it is a straight chain. So 1, 2, 3, 4. 4 carbon over, right? And a bromine on it. So CH3 here, CH2 here, CH2 here, and CH2 here. So from here, in presence of CH3, CH2, OH, and water, you are supposed to make N means straight again 1, 2, 3, 4, and Cn. So CH3 here, CH2 here, CH2 here, CH2 here, and Cn. How you will do this? They are asking the mechanism of it. You don't have to directly tell it will happen because they have given you already. They have given you reagent, they have given you reactant, they have given you even the product. So they are asking how it will happen, that you are supposed to explain. So I will first start with KCN. If you look at this KCN structure, KCN is a resonance hybrid. Okay, resonance hybrid means it has a nucleophile which is ambidentate. Ambidentate means it can donate through carbon also, it can donate through nitrogen also. But how KCN will break? If you see KCN structure, K plus Cn minus, it will break in this way, and in that Cn minus also there is a resonance. Let me show it to you. This is carbon nitrogen triple bond. Carbon has a lone pair over here, and nitrogen itself also has a lone pair. So what may happen is this bond may break and go to nitrogen, and it may become in this way: carbon double bond nitrogen. Lone pair will come because of this, and there is a lone pair already, and because of this too many electrons, there is a negative charge on it, isn't it? Carbon will have still its lone pair. It may happen that it will come back and it will form this again. So either carbon can donate or nitrogen can donate. So but we know that from here the bonds will break in this way, right? Resonance will happen. Now out of Cn minus, we know that carbon can also donate, nitrogen can also donate. Who is gonna donate? That's the question. Now if you see here, Cn minus, if carbon donates, bromine obviously is a leaving group, it will go from here and carbon will join here. So you will get CH3, CH2, 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 Cn, which is your answer. But they may ask why nitrogen will not donate. Because if you see here, if carbon donates, the bond forms between carbon and carbon. But if nitrogen donates, the bond will form between this carbon, which is star carbon, and the nitrogen. Now obviously anyone can donate, but whose bond will be more stronger, will be more stable, right? So carbon-carbon bond, this one is very much stronger as compared to this carbon-nitrogen bond. So therefore, they will prefer to attack from carbon, not through nitrogen. So you will say Cn minus, carbon will donate here. Why? Because bromine is electronegative, so delta negative charge, delta positive charge. Carbon has electron with it, so it will get attracted towards here, and you will get your this product. So this is your answer. Simple. So you have to just write few statements. Let me show you the ideal answer. First, you will say KCN is the resonance hybrid of the following two contributing structure. Either carbon can donate or nitrogen can donate. Next, Cn minus is the ambidentate nucleophile. You have to mention this, okay? Therefore, it can attack the carbon atom of CBr bond in NBuBr either through C or N. Since CC bond is stronger than carbon nitrogen bond, therefore attack occurs through carbon to form N-butyl cyanide. Thank you.